Good morning, chemistry students. Today we are looking at the last two concepts that will be in our Unit 2 content. This deals with standard SC3C2. We are focusing on calculating the empirical and molecular formulas for compounds. Hopefully by the end of this lesson, you'll be able to describe the difference between an empirical formula and molecular formula, determine how to get the empirical formula from percent composition, and determine how to get the molecular or empirical formula from percent composition and molar mass. So hopefully some of those terms seem familiar to you because our last couple lessons we looked at calculating molar mass and calculating percent composition. So basically what we're doing right now is we're looking at going backwards. So some terminology for you. So a molecular formula is the true chemical formula of the compound. It tells you the exact number of atoms of each element in the compound, where the empirical formula is the lowest ratio of atoms in the compound. We use this frequently with our covalent compounds because they can share various number of atoms, and it gives us an idea of the ratio of the elements in the compound. So molecular formula is the real chemical formula. The empirical formula is the lowest ratio of atoms. So like if I'm looking at an ionic compound like sodium chloride, my empirical formula is NaCl. My molecular formula is NaCl because they have a 1-to-1 ratio of each. But there are other compounds, like I said, with our covalent, where we have a variety of atoms shared, so we get a variety of formulas. So an example with one of our covalent ones would be ethane. This would be a compound you would not necessarily be expected to know how to name properly. But C2H6 is its real chemical formula. It has 6 hydrogens and 2 carbons. But if I'm looking at the empirical formula, that's a ratio of the number of carbon atoms to the number of hydrogen atoms. So for every 1 carbon, we have 2 hydrogen. And that's what my empirical formula would be. It would be for every 1 carbon, we have 3 hydrogen. It would be CH3. Now, actually, what we're going to be doing is we're going to be getting this formula from our percent composition. So basically, this is the process to undo calculating your percent composition. In a real lab type situation, there would be machines that would give us the percentage of a compound, percentage of each element within a compound, which would allow us to determine what that particular compound is. Now, there is not a shortcut. There is no quick and easy method. It's just a series of very predictable, very repeatable steps. And you want to make certain you get these steps in your notes. So to go from the percent back to the empirical formula, all you have to do is first take and divide each of the percents by the element's atomic mass. That means you're going to need your periodic table so that you know each of the element's atomic masses. Next, once you've done this for each of the elements, you're going to look at all of your answers and you're going to see which one gives you the smallest number. Then you're going to divide all of your answers by that smallest number. What this does is it gives you the ratio of elements to each other. So we divide by mass, we divide by small, and we should get a number that's a subscript. Bad news reads, we should get a number that's a whole number. That whole number is what we use to become our subscript. So divide by mass, divide by small, and most of the time, that number becomes my subscript. Now, there are a few times when it doesn't, so you do want to be mindful of these times when you're dividing by your small. If you get something that's not really close to a whole number, then that means you might have an extra step where you have to multiply by something to get an equal number of atoms or a whole number of atoms. So like if I get something that's like 1.5 or something really close to 1.5, like 1.49 or 1.52, that means I'm going to have to multiply it by 2. That way I can get that 0.5, that half, to become a whole. Same idea, if I get something that's really close to a quarter, I'm going to have to multiply it by 4. If I get something that's close to a third or 2/3, I'm going to have to multiply by 3. That gets rid of those partial atoms and makes them become a whole number. Now, for first year chem, we do not see this very often. 99% of the time, your steps are just the first 3. divide by mass, divide by small. Those whole numbers become your subscripts. Now, the thing you do want to know is that when you're writing your chemical formula, write the elements in the order that we give you the percent. So we actually give you the elements in order of how they appear in the chemical formula, which makes your life a little bit easier. So if I tell you that S is first, write S first. If S is in the middle, write it in the middle. So let's look at an example of empirical formula. So example number 1, I'm giving you the percent compositions. And what you're having to do is you're having to work backwards to give me that empirical formula. How many atoms of each element are in the compound? So I take each of my percents and I divide them by the atomic mass. So if I look at my periodic table, my mercury has an atomic mass of 200.59. So I take my 67, divide by mass. I do the same thing for the sulfur and the oxygen. So I have all three numbers and I've divided them each by their respective molar masses. And I've lost, there we go. Well, now I have to look at these three numbers and I have to figure out which is the smallest, because I'm going to now divide, step 2 is divide by the small. Well, it happens to be fairly easily because I have the same number twice. 0.34 is the smallest of my three answers. So I'm going to divide all three numbers by that smallest number. Divide by mass, divide by small. So for my Hg, I get 1. For my S, I get 1. And for my O, I get 3.97. Well, 3.97 is really, 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 really close to 4. It's not close to a half, a quarter, or a third. So we're going to round that to 4. And those numbers become my subscript. This thing is telling me that, that I have 1 atom of mercury, 1 atom of sulfur, and 4 atoms of oxygen. So my empirical formula is H1S1O4. Yes, you don't have to write the ones, but you are more than welcome to. So let's look at a second example. The process is always the same. Divide by mass, divide by small. That whole number becomes your subscript. So we're finding the empirical formula of a compound that contains 62% carbon, 13% hydrogen, and 24% nitrogen. Now, when you are dividing this first step where you're dividing by the mass, please keep 3 or 4 numbers. Don't round to a whole number because you're going to skew your answer. You're better off keeping more decimal places than not. So my carbon's mass is 12.01. I divide 62 by 12.01. I do the same thing for my hydrogen. So 13.8% divided by 1.01. And last but not least, I divide my nitrogen, my percent, by the mass. Now I got to figure out what is my smallest number. Well, in this case, my smallest number is 1.72. So I take 1.72 and I divide it into each of the answers. So 5.17 divided by 1.72 gives me 3, or something that's really, really close to 3. Hydrogen, I get 7.94, which is really, 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 really close to 8. And my nitrogen, well, a number divided by itself gives me 1. Those numbers become my subscripts. This is telling me I have a ratio of 3 carbons to 8 hydrogens to 1 nitrogen. So my chemical formula would be C3H8N1, or just N. Alrighty, so you guys pause the video and try number 3 and see if you get it correct. So remember, our steps are to divide by mass, divide by small. Those whole numbers become my subscripts. So I write all of my percents down so that I can actually start my calculations. For each element, I'm going to divide them by their atomic mass. If I don't have them memorized, I look at my periodic table. Even if I think I have it memorized, double check your periodic table. That's why you're given the periodic table. So for each one, I divide them by their atomic mass. So for carbon, I get 2.01. For my hydrogen, when I divide it by 1.01, I get 6.979. And for my oxygen, when I divide it by 16, I get 2.91. And last but not least, my nitrogen, I divide it by 14.01 and I get 0.97. So step one is done. Now I look at each of those answers and I see, what is my smallest number? Well, this time it's 0.97. So I'm going to divide all of these by that same small number, all. And it popped up all at one time, but whatever. I divide each by 0.97, and that gets me something that is really, really, really close to my subscript. So for carbon, it gives me exactly 3. For hydrogen, it gives me exactly 7. For oxygen, it gives me 3.06. 3.06 is not close to a half, a quarter, or a third. So it's much, much closer to that 0 number, that 3.00. That's why we round it to a 3 to get that whole number. And my nitrogen, it's divided by its own number, so it's 1. Those numbers become my subscripts. So the chemical formula of serine is C3H7O3N1. Or you don't have to write that. So that's getting your empirical formula from your percent compositions. But to get that molecular formula, to get that true chemical formula, there is one extra step. So remember that molecular formula is that true chemical formula. And in order to find that molecular formula, I have to give you an additional piece of information. I have to tell you the mass of the compound. So this is something that is typically given to you in the prompt. Because what it does is it allows us to know what we need to multiply our subscripts by. So if you actually look on your formula sheet, there is an equation that is called multiplier. And that is actually the equation that we're going to be using. To get your multiplier, you take your molar mass and you divide it by your empirical mass. So the molar mass is the number that's in the problem. Molar mass is always given to you. The empirical mass is something that you have to calculate. Well, what you're doing when you're finding the empirical mass is you're basically just finding the molar mass of the empirical formula. So molar mass is the real formula. Empirical mass is the one that shows me the lowest ratio of atoms. Once you determine what your multiplier is, then you multiply by each subscript by that multiplier to go from the ratio formula back to that true chemical formula. So let's look at this example here. We have the compound that we know its empirical formula of, but we need to find the molecular formula, and we're given its mass. So the mass is 174.36. That is my molar mass. The number that's in the problem is always my molar mass. I have to calculate my empirical mass. That means I need to find the mass of that compound right there. And to do that, I just add up 3 carbons, 8 hydrogen, and 1 nitrogen. I encourage you to write that calculation so that you know you're doing it correctly, but also if you do end up getting the wrong number, I can see where you made the mistake. So remember, molar mass is the sum of atomic masses. Same thing for empirical. It's the sum of atomic masses. It's just not the real chemical formula. So we take our molar mass, which was given to me in the problem, and I divide it by the empirical mass. This tells me that my multiplier is 3. That means I need to multiply each of those subscripts by 3 to get that true empirical formula. So instead of 3 carbons, I have 9. Instead of 8 hydrogens, I have 24. I can do mental math. And instead of 1 nitrogen, I've got 3. Notice empirical formula and molecular formula, they're really, really similar. They're just different by that multiplier. So you guys try number 2. Empirical formula of Cl, that's an L, not an I, ClCH2. So we're given the molar mass in the problem, and we need the empirical mass to get from the empirical formula to the molecular formula. So I add up 35.45 plus 12.01 plus 2 times 1.01, and that's how I get that 49.48. I take my 98.96 and I divide it by that 49, and I get 2. That means I multiply each, I keep losing my marker today, each of my subscripts by 2. So I had 1 chlorine, well, now I have 2. I had 1 carbon, now I have 2. I had 2 hydrogens, now I have 4. So my empirical formula goes to the molecular formula of C2, sorry, bad misreads, Cl2, C2H4. All right, last example, I think, and this is one where we actually take both skills and we put them together. So I'm giving you the percent and a mass, but I can't do that molecular step. I can't do empirical mass until I have that empirical formula. So we're going to put both skills together. We take divide by mass, divide by small. Those whole numbers become my subscripts. So 3 steps. Divide by mass, divide by small, and then my whole numbers become my subscripts. So my whole numbers are 1 carbon, 2 hydrogens, 1 oxygen. Remember, I write them in the order that they appear. I give them their subscripts. That's my empirical formula. To get the molecular formula, I take my 90 and I divide it by the empirical mass. So 1 carbon plus 2 hydrogens plus 1 oxygen gives me an empirical mass of 30. So 90 divided by 30 gives me 3. That means I have to take my empirical mass, my empirical formula, and I multiply each of those subscripts by 3. So we get 3 carbons, 6 hydrogen, and 3 oxygens. That is my last example for today. Make certain you take advantage of Ms. Rains in the meet and ask questions. This is the last skill for this unit. Woo-hoo. And we are looking at having potentially a at-home physical lab later this week.